Hello everyone, welcome to ECJ Squatty channel. Vanakkam, Namaskar, Shwagatam. So today in this video, we are going to discuss about principles those are present in SDN, that is software defined network. So if you didn't watch the previous video that is about overview of software defined network, please subscribe to my channel and view all the videos, watch it, please like, share, comment. Okay. So today we'll start with the principles in SDN. So what all the principles which involves in the SDNs, we will see it. Okay. So the ONF, that is Open Network Foundation. So high level view of SDN. So this Open Network Foundation has given all the principles which we are going to discuss now. About those principles, their implications are briefly summarized in this video. Okay, the first principle of this SDN is decoupling of controller and data planes. So this principle calls for separable controller and data plane. So this is the main criteria of this SDN. So what is the software defined network? So what we are going to do, so when compared to the traditional network which we are following, what we are doing, we are trying to put some controlling mechanism, because that controlling mechanism is not there in the traditional network. Because of that, dynamic nature of the network fails. That's why we are going for SDN. So this principle, that is decoupling of controller and data plane, calls for separable controller and data plane. So however, it is understood that control must necessarily be exercised within the data plane systems. Okay, so we need to put the control in the data plane itself. Okay, so that is between the data plane and the SDN controller, and network element is defined in such a way that SDN controller can delegate significant functionality to the network elements, okay, while remaining aware of the network element state. So whatever we are going to do, we need to know the network element state. So whether it is in active state or whether it is in sleep state, so all these things we need to take care. So that is the first principle, decoupling of controller and data planes. Okay, next one is logically centralized control. So in comparison to local control, a centralized controller has a broader perspective of the resources under its control and can potentially make better decisions about how to deploy them. So we need to take care how to deploy the centralized control unit, how to implement the logic upon the control unit. So scalability is improved both by decoupling and centralizing the control, so which allows for increasingly global but less detailed views of network resources. Okay, software defined network controllers may be recursively stacked for scaling or trust boundary reasons. Okay, so this is the second principle, that is logically centralized control. Okay, the next one is exposure of abstract network resources and state to external applications. So applications may exist at any level of abstractions or granularity. So attributes often described as differing latitudes, with the idea that further north suggests a great degree of abstraction. So because an interface that exposes resources and state can be considered a controller interface, the distance between application and control is not precise. So that also we need to take care. So the same functional interface may be viewed in different lights by different stakeholders. So we have different stakeholders in order to get the functional interface. Okay, so just like controllers, applications may relate to other applications as peers or as elements and servers. Okay, so the principle of abstracting network resources and state to application. So how we need to get the application from the application interface, which allows for programmability of the network. So with information about resources and their states, applications are able to specify requirements and request changes to their network services via the software defined network controller and to programmatically react to the network states. So further, the concept of hierarchically recursive application or hierarchically recursive controller layers and trust domains also allows application programs to be created that may combine a number of component applications into a more comprehensive service. So the SDN architecture clarifies the meaning and implications of these principles by identifying the basic functional entities and the information and operation that need to be exchanged over various interfaces among them. So the architecture further decomposes these functional entities into a not necessary comprehensive set of functional components, but those need to be a functional component, that those need to be a set of functional components. Okay, so this SDN architecture incorporates the concept of trust domain boundaries, which is vital to widespread commercialization. So the architecture defines components entirely within the particular trust domains with well-defined reference point to other trust domains. So strong abstraction barriers help to protect the commercial and business interest of stakeholders. So while recognizing and accommodating widely varying trust relationships, the uniformity of the architecture also facilitates the design and audit of security measures. So the high-level model of all vertical SDN architecture interfaces is the exposure of an information model instant by a server to a client. So upon which the client can perform create, read, update, delete, that is CRUD, create, read, update, delete, and class specific operations. So this emphasizes the importance of the common information model throughout the architecture. So from this perspective, the management function is responsible for instantaneous information models and policies that define the capabilities exposed across the interfaces between the planes. So especially across trusted domain boundaries. Okay. So hierarchical lever serves two purposes. One is scaling and modularity, and the second one is security. So scaling and modularity is nothing but each successively higher level has the potential for greater abstraction and broader scope. And security, each level may exist in a different trusted domains. So the level interface is a standard reference point for inter-domain security enforcements. Okay. So within the recursive hierarchy, we will see one roles. So this is the block diagram which is given for recursive hierarchical roles. For example, if you take SDN controller, so hierarchical level n+1. So we will be having a lot of levels present in, that is ACPI to level DCPI. This is nothing but application interface and data plane interfaces. So we have a different level. So the data plane. So DCPI, this gives to the this implicates the data line. So we have SDN controller hierarchical hierarchies. So why we are going for this hierarchy? This is a set of rules. So within this recursive hierarchy, an SDN controller or an application may consider itself as the direct controller of an information model instance. So that represents a sustainability abstracted virtual network, that is VN. From this frame of reference, it supports a data controller plane interface, that is DCPI. So DCPI is nothing but it is a data controller plane interface. So be it a virtual network element, another SDN controller, or even an application, the subordinate entity sees the superior entity as an application. So supported by an application control plane interface. So from a global perspective, either or both of these interfaces may appear as intermediate CPIs, that is control plane interfaces. It follows that with the exception of physical NEs, that is resources, okay, network elements. So a given entity may occupy any of the data controller or application planes depending on perspective. So all north-facing interfaces expose managed object instances for client use, but at different levels of abstraction. So at any level of the recursive hierarchy, a resource is understood to be subject to any one by controlling entity. So while an SDN controller may support any number of DCPI, that is the data controller plane interface instances, no resource on the subordinate plane is subject to more than one of them. So nor is the resource subject to other SDN controllers. Okay. So allocation of resources to particular domains is a management function. So we need to note that resource sharing is also present. Okay. So some applications may require all or nothing semantics. So it need all the required facilities present, or else it won't use anything. So some application may require all or nothing semantics, that is transactional integrity. Okay. So expansion of global and abstract operations invoked by such an application implies transactional semantics at each lower level of abstraction. So continuing all the way down into the hardware, further failed transaction must not leave behind standard resources. So each level of hierarchy is recursively responsible for orchestrating the transactional semantics of its subordinate entities. So we need to note that distributed transactional integrity carries a heavy cost and may not be required in all the cases. So if transactional integrity is not supported intrinsically, implementers should consider other means to recover from transaction failures, possibly including manual resource recovery. So in some cases, inbuilt timeouts may suffice to recover standard resources. This is all about short notes, I can say, or short video about the principles involved in software defined network. Thank you. Oh, I'll meet you in the next video. Until and then, bye.